Hello everyone, welcome to this session. We're still discussing about the introduction to the simple machines. In our previous video, we saw the meaning of machines. We said there are two types of machines, simple and complex. We then moved on to the simple machines. So let's discuss further today about the various the terms applied in the simple machines. The first term is the mechanical advantage. Mechanical advantage, abbreviated as MA, this is the ratio of the load and the effort. So that's simply the definition of mechanical advantage, is the ratio of load and effort. Mathematically, as you can see here, mechanical advantage equals to load upon effort. So from there, you can calculate the mechanical advantage if you are given either of these two, maybe load or effort. You can find you can, if you are given two of them, you can find the mechanical advantage. If maybe you are not given any of the two, you can find it if you have the mechanical advantage. We'll see the examples. Uh, Mechanical advantage, you have to note it that it has no SI unit. Now, the other term, before that, let's see the example. A simple machine raises a load of 100 Newton by using a force of 50 Newton. Calculate the mechanical advantage. So simply, that a given load is 100 Newton. If it is 50 Newton, we are required to find the mechanical advantage. So from uh, uh, equation that is mechanical advantage equals to load over effort. So you take a mechanical advantage equals to load. We are given 100 Newton, so 100 Newton you divide by the 50 Newton, we get the mechanical advantage is 2. Since we said the mechanical advantage has no SI unit, as you can see here, so mechanical advantage is 2, and you see here Newton and Newton, they'll be cancelled out, so it remains 2. So that's why mechanical advantage has no SI unit. The second example, a force of 20 Newton raises a load of 100 Newton. Calculated the mechanical advantage of the machine. Solution, mass given is 100 kilogram. Effort is 20 Newton. We're required to find the mechanical advantage. But we know that for my equation, mechanical advantage equals to load over effort. Now, first, what we have to do, we have to change the mass given. We have to change it into Newton. So 1 kilogram equals to 10 Newton. So 100 kilogram equals to how many Newton? So 100 times 10 Newton upon 1 kg. So load therefore will be equal to 1,000 Newton. Now from there you can move on saying that mechanical advantage equals to load over effort. So mechanical advantage will be equal to 1,000 Newton. You divide by 20 Newton, you get the answer is 50. So mechanical advantage is 50. Moving on, the other term is the velocity ratio. Velocity ratio, this is the ratio of the distance traveled by effort and the distance traveled by load. Or you can simply define it as the velocity ratio is the distance moved by the effort, the distance moved by the load. Mathematically, the velocity ratio equals to distance moved by effort upon distance moved by load. Example, in a certain machine, a force of 100 Newton moves a distance of 5 centimeter in order to raise the load of 100 Newton through a height of 0.5 centimeter. We are required to calculate the velocity ratio of the machine. Solution, distance from the effort, we know that is 5 centimeter, while that distance moved by the load is 0.5 centimeter. Now, from our equation, we know that velocity ratio equals to distance moved by effort upon distance moved by load. So velocity ratio will be equal to 5 centimeter, you divide by 0.5 centimeter, we get our answer, the velocity ratio equals to 10. The other term is the efficiency of machine. The efficiency of machine, this is the ratio of the work output to the work input. Work output equals to simply load times distance moved by load, and the work input is equal to effort times distance moved by effort. So that's simply how you can find the the efficiency of machine. And the efficiency of machine mathematically can be shown like this: work output over work input multiplied by 100%. And we know that load over effort is equal to MA, that is the mechanical advantage. So when you substitute that mechanical advantage times C1 upon V velocity ratio, times 100%. So mechanical advantage uh, uh, will be equal to mechanical advantage time upon velocity ratio times 100. Here there's a slight mistake. So mechanical advantage upon velocity ratio times 100 equals the efficiency of machine. So you can find the efficiency of machine simply by taking the mechanical advantage upon velocity ratio times the 100%. So I hope it's clear. The perfect machine has 100% efficiency. Therefore, MA is equal to VR, that is the mechanical advantage equals to velocity ratio. Now, we have to note that most machines are imperfect machines. Since the efficiency is less than 100%, this is due to friction and heat loss and the other loss of energy. So that's why there's no imperfect machine. There's no perfect machine. The machines are always imperfect. Now let's see the example. A certain machine with a force of 10 Newton moves down a distance of 5 centimeter in order to raise a load of 100 Newton through a height of 0.5 centimeter. Now you are required to calculate the mechanical advantage, the velocity ratio, and the efficiency of machine. Solution, we have to collect the data. The data given is that the effort is 100 Newton, the load is 1,000. I mean, effort is 10 Newton, the load is 100 Newton. So the distance moved by effort is 5 centimeter, while the distance moved by load is 0.5 centimeter. Now from there, we get that we have to find the efficiency of machine. So efficiency of machine is equal to MA upon VR times 100%. But we know that MA is equal to load over effort. So MA is equal to 100 Newton, you divide by 10 Newton. So MA will be equal to 10. There's no Newton here. Now, velocity ratio equals to distance moved by effort upon distance moved by load. So distance moved by effort is 5 centimeter. You divide by 0.5 centimeter, you get the velocity ratio that is 10. Now, efficiency of machine, simply you take the mechanical advantage which you obtained here, that is 10. You divide by the velocity ratio that is 10, and if you substitute the values you get the efficiency that is 100, which is actually ideal because machines are always imperfect due to the reasons we mentioned before. So I hope it's clear, everyone. Thank you for listening. That's all I have for this video. Seeing the various terms for the simple machines. Simply the mechanical advantage is mathematical expression. The velocity ratio is equation also, and the efficiency of machine, they are all related together. So I hope it's clear, and thank you.